All right, we're going to be looking at the second exercise from Lesson 6 of Unit 3 of our Data Structures and Algorithms course. For this exercise, we're supposed to create a class called Word Arranger. It has one constructor which uses the string parameter of words that are space separated to create a complete binary tree, not a search tree, where each node of the tree contains a word from the string array. So we want it to be a complete binary tree, which means we need to fill it in level order from left to right. It will not be a search tree. Instead, we'll be filling this tree in the order in which the words arrive, where each node of the tree contains a word from the string array. Or should be saying string parameter there, I think. Okay, then we're going to write four methods: to pre-order, to in-order, to post-order, to level order, that return a string of the words in the complete tree separated by spaces in those traversal orders. Use iterative methods so that you do not need to create any additional fields. The depth first traversal should use a stack of index values. Okay, so we get to practice our traversal algorithms in a complete tree. So let's get right to it. This is called Word Arranger. Public class Word Arranger. We're going to be doing some traversals, so we'll need to use a stack to do our depth first traversals. So I'm going to import java.util.deck. There is a java.util.stack class if you want to use it, but the preferred is deck. But you will see people use stack from time to time. Now, in order to implement deck, you have to use something that's an abstract interface, so we need a concrete class that implements it. So I'll use java.util.linked-list. Okay. All right, so I'll make an array of strings that will be this is going to be our tree, okay? And then public word arranger is going to take in a string argument that is going to be space separated. And we're just going to add them to our array. So the way I would do that is I would say string, I would just say array, actually I've already got it, equals arg.split. And that's going to put it in order, and that's going to do it. That's going to put it right in level order for us, right down the line. Let's take a look at that to see if you're not quite sure how that would work. But we've got, we're going to get an array. And let's just say the letters are A, B, well, it's going to be space separated. So let's say they're just letters that are space separated: A, B, C, D, E, F. So A will go here, then B, then C, then D, then E, then F, etc. This is index 0, 1, 2, 3, 4, 5. So it perfectly makes our tree for us. So now we're ready to go to make our different methods. We need to make a pre-order. Okay, so public string to pre-order. All right. First, I'm going to make a string that I can build with called toReturn. I'm going to make my stack, so it'll be a deck of type index. So it'll be an integer. We're going to be making a stack of indices, and we can't put ints into Java's collections. They require the wrapper object. If you want to use ints, you just got to make your own stack, and that's not hard. You can make a stack of ints right quick. You make a little linked list, or use something else to do that. So we'll just call it stack, and we need to instantiate linked list. All right, now let's review the algorithm We know the pre-order algorithm is so nice to write recursively. You just check if the current node is null, else you recursively call pre-order on the left, you visit the node, then recursively call on the left, recursively call on the right. But we're not going to be doing that. We're going to be doing it iteratively. So what we're going to do is we're going to make a stack, and we're going to start by putting the root on it. My root index is 0. Okay? You can think of that as the A. Then we're going to go into a loop, and we're going to loop while this stack is not empty. Okay? We'll pop off an element of the stack. We're doing pre-order, so we'll go ahead and visit it. Then we're going to need to be clever here. We're going to add to the stack the right child, which in this case is index 2, a C, then the left child, so that when we pop from the stack, we end up popping the left child first. So we visit, then we add right, then we add left. So let's go ahead and visit. Well, first I got to add the root to the stack. Well, let's do this. If array.length is equal to 0, let's just return an empty string. Okay, so that takes care of the case that somebody tries to run this program with absolutely nothing in their string at all. Now we'll handle the rest of that. I actually don't need an else because I already returned, so I'll just put it here so I don't have to indent again. I'm going to push to the stack my index 0. Okay. Then I'll say while the stack is not empty, or while stack.size does not equal 0. All right, we'll say int my current node is an index, or current index. We'll say stack.pop. We'll go ahead and visit it. So I'll say to return plus equals array bracket current. And we're just going to add a little space there so the words don't run together. Then we'll add the right child to our stack. So we'll say stack.push. Well, we need to be careful here. What if our right child was outside of the bounds of the array? Well, we need to make sure about that. So we'll say if current times 2 plus 2, that's the right child, the index times 2 plus 2, is less than array.length, then we need to add it to our stack. Now, normally we're used to checking if the right child is not null and adding the stack. Well, this is how we're going to check if it's not null in a complete tree, because in a complete tree, every single node is not null until you run out of nodes. You've reached the end of them. So we'll say stack.push current times 2 plus 2. That's the right child. All right, and again, if you don't remember, that's fine. Just pick a child, pick an index. Like this here is index 0. This is 1. How do I get to this right child? Well, if you multiply 1 times 2 plus 2, you get 4. And this is 1, 2, 3, 4. The left child is times 2 plus 1. 2 times 2 is 4 plus 1 is 5 to get the left child. So, just remember it's something like that. You'll always be able to figure it out, I promise. All right. Now, I don't want to say else if, because then I would only add the right child if I didn't add the left. So be careful. We want to do a completely different if branch here. If current times 2 plus 1 is less than array.length, stack.push current times 2 plus 1. All right, that should be it. You wanna I'll tell you what, let's give it a try. Okay, what did I mess up? Oh, I forgot to return my string when I'm done. I'm gonna return to return. All right, so let's go ahead and run it. Now I think I gave a test case, but I'm not exactly sure that this works. We'll try it. All right, so I'm going to add them just like that. Hell, this is from, of course, from Princess Bride. Hello. Oh, I'm forgetting the word name. Hello, my name is. Hello, my name is. Oh, wait, that's all. That's weird. It's all out of cattywampus order. Did I do that on purpose? The in order should be the one that's perfect. Oh, the level order should be the one that's perfect. There it is. All right, we'll get that one. We'll get that one. Oh, yeah. Yes, yes, yes. Gotta put quotes around it. All right, there it is. We can inspect it. Hello, my name is Inigo Montoya. You killed my father. Prepared to die. Hello. Sorry. My name is Inigo Montoya. All right. Hello, my is killed my Inigo father. Prepared to name Montoya to die you. Wow, is that what I got before? Hello, my is killed my Inigo father. Prepare name Montoya to die you. Frankly, I think that would have been a cooler line to say while you killed someone. You could have said, "Oh, now I'll give it to you in order, then post order." And finally, when he gets to like back to level order, you know what he's saying. Okay, enough of that. Let's write another one. Let's write our in order. If you've been paying attention to these videos, you might have noticed that we've written a lot of pre-order, post-order, level order iteratively. Probably pretty important. I think we're calling it two in order. All right, everybody hates the in order. That's the one that's all weird. You gotta like dive left, but we'll do it. So first thing we're gonna do is we're gonna make something to return. If the array dot length is equal to 0, just return a blank string. Otherwise, what we're going to do is we're going to make a stack. So we'll say dec integer stack equals new linked list. And what we're going to do is we're going to make a current value. So int current, we're going to start with it being 0. Let's see here. I think we can just, so I wanted to start with a current being 0. I usually say, well, current is not null or the stack is not empty. But what we want to do is we want to take this value here and we want to dive as far left as we can first. So I think I'm going to try something a little bit different. I think we can do this. We can say while current is greater than or equal to 0 and current is less than array dot length, or not stack is empty. Okay. So first thing I'm going to do is I'm going to put current on the stack. All right, so we'll push the current. Actually, I don't think I want to do that. I want to say while current is less than array dot length, and I'm going to say stack dot push current, and then we're going to dive left. Current equals current times 2 plus 1. So that's going to just keep going left as far as it can until it gets to an empty spot. The empty spot is because it's past the array. So we're pushing all of those things. We're going to push A on the stack. Then we're going to push B on the stack. Then we're going to push D on the stack. Finally, once we've got them all pushed, we're gonna finish, and we're gonna go ahead and we'll finally visit. Okay, so we'll go ahead and visit at this moment. So we'll say toString. We'll say current equals stack dot pop, and we'll say toString plus equals array bracket current. That's be visiting it plus quote quote. And then we're going to go ahead and, no, not toString, but toReturn. Then we're going to dive right. Current equals current times 2 plus 2. So that's us diving to the right. So, for example, let's say we had, well, there isn't really much to do to dive to the right, is there? Because we're always going to, after that, come backwards. And so after we pop, we'll dive right. There we go. Yeah. So it won't dive right when we're at the bottom, but it will after we get to the B. That'll be the diving right that way. All right. That should be it. So I think all we have to do is return to return. All right, let's give it a try. All right, so this is in order. Killed is my father, Inigo. Prepare a hello to Montoya. Die you name. Die name you. Die name you. So what is killed is my father, Inigo. Prepare hello to Montoya. Die name you. So that looks pretty good. Hopefully you understood that part of the algorithm. You know, just trace it out if you need to. But the basic idea is that we start with current. You know, I'll say current is equal to 0, and we have an empty stack. We then ask, while current is a legal index and or stack is not empty, we're going to say current. First thing we're going to do is we're going to put it on the stack and dive left. So it'll be 0, then it'll be 1, then it'll be 3, and then when we get to 5, that's not a valid thing. So we end up finally popping off. We visit 3, so that gives us D. 3 is gone. We dive right. We try and dive right, but it doesn't work because there's nothing to dive right to. Let's see if that does that. Yes, because when I dive right, we'll go. This will be invalid because it'll say while current is less than array length. So when I dove right and I went to, let's see, I did 3 times 2 is 6 plus 1 is 7. That's my index. Well, that's not going to work because it violates that, right? Oh, but the stack's not empty, so it's okay. But this is not going to be true, so we'll just pop a new element, taking it right back to this value here at index 1. We'll visit it, then we'll dive right, but the 4 is okay, so that time we visit it. So that's how that works. All right, we have one more to do, and that is public string to, actually I have two more to do, post to post order. Now with post order, you need a couple of different stacks. So you'll say dec integer stack. Dec integer to visit. And it's basically the same as this. It's basically the same as the pre-order. So in fact, I'm just going to copy it. I know that's bad, but instead of actually visiting, what we're going to do is we're going to say to visit dot push current. And we're saying right then left, but I think this time what we want to do is left then right. And then what we got to do is we got to say while to visit is empty does not equal 0, or is the size not equal 0, it is not empty. We'll say to return plus equals array bracket to visit dot pop. And then when we're done with that, we'll return it. Oops. Got too much stuff there. Oh, I got rid of my to return though. There, I need that. Don't want to lose that. All right. So we'll try that now. Oh, can't do that. All right, where are you? Here it is. So we got to post order, and let's check that result. Killed my is father, prepare Inigo to die Montoya, you name hello. What do we get here? Killed my father is prepare Inigo my to die Montoya, you name hello. That sounds about right. Killed my father is. Killed my is father. It would be cool. It's killed my father. It's be like Jedi. All right, and then the last one, of course, is level order. And, we already made the tree in level order with an array, so it couldn't be easier. Public string to return. Oh, not to return, to level order. So we have string to return. And we'll just say for int I equals 0, I less than array dot length. I plus plus to return plus equals array bracket I plus a space return to return. Huzzah. And I can't spell string. So now we have the glory of all the different ways that we can mess with it. But there it is. Hello, my name is Inigo Montoya. You killed my father. Prepare to die. Will you stop saying that? All right. That's it. So I hope you got something out of these complete trees with an array. That's really what we need to use. Binary trees with an array really are necessary to make them complete trees, which we use to make heaps. Also, remember your algorithms, know them recursively and iteratively. They're so important for all sorts of different things.